The seventh part, f of x is equal to x4 minus 4x square. First find first derivative, which is 4x cube minus 8x by applying the power formula on this function. And the second derivative is 12x square minus 8. So for stationary points, we will put first derivative is equal to 0. So that will become 4x cube minus 8x is equal to 0. And simplifying this equation, we have values of x. So either x is equal to 0 or x square minus 2 is equal to 0. And from here x square is equal to 2 and x is equal to plus minus square root 2. So actually we have three values of x. X is equal to 0, x is equal to plus square root 2 and x is equal to minus square root 2. So first put x is equal to 0 in second derivative. Actually we check all these three values by putting it to second derivative for extreme values. So first put x is equal to 0 in second derivative, and second derivative was 12x square minus 8. By putting x is equal to 0, that will return minus 8, which is less than 0. So f of x or given function has relative maximum value at x is equal to 0. And to find this maximum value, for the maximum value, put x is equal to 0 in given function. So f of x was x4 minus 4x square. By putting x is equal to 0, we have f of 0 is equal to 0, which is a maximum value. So we can declare here maximum f of 0 is equal to 0. And now we check the second value, which is square root 2 in second derivative. We have 12 into square root 2 whole square minus 8, and by simplifying that will return 16, which is greater than 0. And as second derivative is greater than 0, so function or given function has relative minimum or at x is equal to square root 2. And for that minimum value of the function, we will put x is equal to square root 2 in our given function, and that is minus 4, which is a minimum value. So minimum value of function, minimum f of square root 2, which is minus 4. And the third and the last value of x was minus square root 2. Again put in second derivative. 24 minus 8, which is 16, greater than 0. So f of x has relative minima at x is equal to minus square root 2. And for the minimum value of the function, put x is equal to minus square root 2 in our given function, x4 minus 4x square, and by simplifying that will return minus 4. So again we have a minimum value of the function, which is minus 4. Now part 8, f of x is equal to x minus 2 whole square into x minus 1. First we simplify this function by opening this square and multiplying to x minus 1. We have x cube minus 5x square plus 8x minus 4. And now apply the procedure. First find first derivative, which is 3x square minus 10x plus 8, and the second derivative 6x minus 10. Now put first derivative is equal to 0 for stationary points. 3x square minus 10x plus 8 is equal to 0. Now simplifying this one to find the value of x by making factorization, we have x minus 2 is equal to 0 or 3x minus 4 is equal to 0. And from here x is equal to 2 or x is equal to 4 by 3. So we have two values, x is equal to 2 and x is equal to 4 by 3. Now we put these two values in second derivative one by one to check extreme value. So first put x is equal to 2 in second derivative, and that returns 2, which is greater than 0. So given function has relative minima value at x is equal to 2. F has relative minima at x is equal to 2. And for the minimum value of the function, put this x is equal to 2 in given function, x minus 2 whole square, x minus 1, and putting x is equal to 2, we have f of 2 is 0. 0 into 1, which is 0. So this is actually a minimum value of the given function. Now put the second value, which was 4 by 3 in second derivative, and this second derivative at x is equal to 4 by 3 return minus 2, which is less than 0. So given function has relative maxima at x is equal to 4 by 3. To find that maximum value, we put x is equal to 4 by 3 in our given function. So f of 4 by 3, putting x is equal to 4 by 3, and by simplifying, that is 4 by 27, which is a maximum value of the given function. So we have one minimum value at x is equal to 2 and one maximum value at x is equal to 4 by 3.